Maclaurin series. Sin x. Let's look. Let sin x be equal a0 plus a1x plus a2x squared plus a3x cubed, where a0, 1, 2, and 3 are constants. So when x is equal to 0, we have that sin of 0 is equal to a0. Because all these here, if you put in 0, will end up being 0, so you're just going to have a0. And sin of 0 is actually equal to 0, so you're going to have that a0 is actually equal to 0. If I differentiate both sides, so d dx of sin x, and then differentiate the right-hand side as well, we're going to have that cos x is equal to a1 plus 2a2x plus 3a3x squared. And we'll do a similar sort of thing when x is equal to 0. We have cos 0 is equal to a1, therefore, because the cos of 0 is actually equal to 1, we'll have that a1 is equal to 1. No, the cos of 0 is equal to 1. So a1 is equal to 1. And then we differentiate again. So differentiate cos x, we're going to get minus sin x, and if we differentiate this, we're going to get 2a2 plus 6a3x. And then we'll do a similar sort of thing. We'll just write that out again so we can see it. So when x is equal to 0, we will have minus sin 0 is equal to 2a2, and therefore a2 will be equal to 0 because the sine of 0 is 0. So the sine of 0 is 0. Now if we differentiate again, so d dx of minus sin x and d dx of 2a2 plus 6a3x, we're going to get minus cos x, we're going to get 6a3, and therefore cos x will be equal to, rather than 6, we're like minus 3 times 2a3, and when x is equal to 0, cos of 0 is 1, so we're going to have cos of 0 is minus 3 times 2a3, and therefore a3 will be minus 1 over 6, or preferably a3 will be minus 1 over 3 times 2 times 1, which is minus 1 over 3 factorial. Rather than keep doing this, we could probably now deduce that a repeated differentiation will give a4 is equal to 0, a5 is 1 over 5 factorial, a6 is equal to 0. So, and a7 is minus 1 over 7 factorial. If we now write out the original statement, so a0 plus a1x, etc., I'm going to do it all the way up to x to the 7, where these a0, a1, a2 up to a7 are constants. We're going to have that sin x is going to be 0 plus 1 times x plus 0 times x squared plus minus 1 over 3 factorial x cubed plus 0 times x to the 4th plus 1 over 5 factorial x to the 5 plus 0 times x to the 6 plus minus 1 over 7 factorial x to the power of 7, etc. And taking the terms which have non-zero constants, we're going to end up that sin x is x minus x over cubed x 3 factorial plus x over 5 factorial minus x over 7 factorial, x to the 7 over 7 factorial. General forms this with n starting being equal to 0 will give these terms, and we're not really interested at the moment, we're just interested in this bit for the next part. Now this is interesting because this is the way that your calculator actually works out the value of sin x. Now to do cos x we could repeat that, but if we just differentiate this, so d dx of sin x will be d dx of all this. So d dx of sin x is cos x, and if d dx of x is 1, this will become 3x squared over 3 factorial plus 5x to the 4th over 5 factorial minus 7x to the 6th over 7 factorial. Now, 3 factorial is 1 times 2 times 3. If you've got the 3, it will cancel, so this will become 2 factorial, this will become 4 factorial, this will become 6 factorial. So cos x will be minus 1 over x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc. And this is the general term, starting with n is equal to 0.